Hello everyone, my name is Hannah Kelly, and today we will be talking about the topic of gene editing in farm animals. So to start off, what is gene editing? Well, it's a precise gene change. It's either an insertion, which means you add something in, a deletion, remove, or a substitution where you change it. The main tool used to do this is CRISPR, or tiny scissors guided to one DNA spot. The FDA labels this as heritable intentional genomic alterations, or IGAs. It's used by editing embryos in the embryonic stage, and then they breed into the next generation and the trait into the next herd and flock. This is better than breeding in general to get to this specific change because it's faster and it's more accurate for single well-understood traits. This comes with benefits in areas especially farming. One benefit is that there be least contagious disease, especially in farming where you have a big herd. You don't want any of your livestock to cause diseases, but if you're editing the gene for the disease, it would lower the disease rates. It would also improve animal welfare and eliminate painful procedures like dehorning in calves and cows. They would also increase food security and climate resilience because you can edit a gene for heat tolerance, and it's also faster than selective breeding, as we just discussed. There are also benefits to humans, such as in public health, because there'd be less antibiotic use on farms. And then there would also be consumer benefits because you would have more stable prices and availability. Also, there's a potential allergy-free option in milk from the BLG-free milk gene. There's also worker and community benefits, fewer high-risk procedures like dehorning, climate resilience again for the heat tolerance gene, and there's also economic benefits due to reduced diseases, which means less antibiotics and less money spent on trying to reduce disease rates. The first animal's edited genes and benefits I'll be talking about is pigs and the specific defenses against PRRS resistance. It's a respiratory disease in pigs, and it also causes abortions and stillbirth and pregnancy difficulty in sows. The specific gene that it targets is the CD163 gene, and it also makes the pigs resist the gene while also maintaining good health. And it's FDA approved as of now. The next animal gene edits I will be discussing is chickens, and this affects bird flu or avian influenza resistance, and that's in the AMP2A gene. And that gene is a host factor used by flu polymerase. This would reduce bird flu outbreaks. It would also help the economy and have economic benefits because there would be less sick birds, therefore spending less money. And the result of this is that 9 out of 10 of the edited birds resisted normal dose challenges, but high dose exposure caused breakthroughs in the disease, and it had a adapted disease, so it's promising, but it's not yet perfect in the study. The final animal that I will be talking about in gene edits is cows, and this comes with the heat tolerance gene, or the slick coat gene that I had talked about before. Its target is the PRLR, or the slick variant, which creates a short, sleek hair and helps for heat dispersion, which lets heat disperse across of the cow without it overheating. The FDA determined this procedure low risk, but it's not yet fully approved. Another procedure is the hornless or the pulled procedure, which used to be a dehorning process, but if they target the pulled or the PC Celtic allele, it would have cows being born hornless, which would take away the dehorning procedure. Another one is for tuberculosis resistance in the NRAMPI, and it's a natural resistance gene, and it increased resistance in edited cattle. but that's also still in the research stage. And then they have the allergen-free milk, or the BLG. This would target the beta lactoglobulin receptor, or BLG, and it's a major milk allergen. So there's a possibility of allergy-free milk instead for people who do have a milk allergy. Another possible gene edit that scientists are looking into is muscle growth and efficiency, or the myostatin, MSTN, which increases muscle mass and weight, and it also has feed efficiency because you don't have to feed them as much for their muscle to grow faster. So it would also potentially lower production costs. It seems like a great idea, but there are risks that have been noted in the study, and it has high potential, but it's also becoming where do we draw the line? Some positives of gene editing is disease prevention and better animal health, like the PRRS in pigs, bird flu in chicken, and less antibiotic use. There's also welfare gains, like in the animals, like the hornless, and not having to dehorn them, or the polled, the slick coat, or the heat tolerant gene. And there's also more productivity and sustainability. There's less disease loss, less money spent on trying to prevent disease loss, better heat resistance, and potential feed limitations, and not having to feed them as much if the muscle mass gene were to be put into effect, safer food supply, and economic benefits for humans. Some negative or risks are off-target edits, so if they go into the embryo and they don't hit the right gene, it could cause very big problems in the animals. And we do screen for that now in modern times, but it still has to be checked line by line in the gene code. Trait-specific trade-offs in the MSTN, the extra muscle genes. It can cause dystocia or lameness, which is like a wobble in their walk. That one's also tricky because you're doing it for the benefit solely of the more meat, more muscle for production, not for helping the animal at all. So that one is a little bit on the sketchy, non-moralistic, humane side, but it still has potential. Also, the PRRS resistance in pigs, it doesn't have any obvious health issues, but it needs to be monitored just in case. And the development and reproduction methods, if it's in the embryo and cloning, it can be not as effective, and it could cause pregnancy loss and parietal problems, which is a welfare concern. There's also ecosystem and market risk, concerns about GMO, gene mutations, overuse, and we need strict labeling. And there's also trade problems because not every country has the same policies, so it would be hard and it would impact trade. Does it hurt the animals, and is it humane? Edits at the embryonic stage are not painful to the animal that is born in the future, and the focus is on the trait, the consequences, and methods used during the development. It is humane when it reduces the suffering of the animal, like decreasing disease, the dehorning method, heat, and stress. And then there's strong welfare oversight that needs to be in place of these animals to reduce the risk. But it's not humane when it adds pain, harm, or chronic stress, like extreme growth traits with the muscle mass or poor welfare of the animals. Countries and their policies. The U.S., as of now, has FDA regulations on IGAs as new animal drugs with a higher based pathway. For example, the slick coat is low risk, and the PRRS in pigs is approved. In Europe and the UK, the EU debates new genomic techniques. They're a little bit more on the fence with it. They also wanted to start in plants. They have much stricter rules than us, and the UK Precision Breeding Act progressed for plants. As I said, only in plants is what they wanted, but they do think that it will eventually get to animals, but they do still emphasize animal welfare first. And here are my references.